Welcome back, physics fans, and this is number 8 from the work power energy notes. This is the back worksheet on the back of the notes. And it's a roller coaster question, so it's a very popular type question that you see on tests because it's a good one for grade 10 energy as well as grade 11 and grade 12. So here we go. We have a picture of a roller coaster, and the roller coaster starts from rest at point A. And what is its speed at point C if the track is frictionless? So it goes down, probably catching up speed, and then at the bottom of there, it goes back up to point C. So we're not looking at the bottom, which is probably point B. We're trying to see if it's frictionless, what is the speed at that point? This is a conservation of energy question. So the energy before equals the energy after. So the energy before, since it's frictionless, it's just going to be mechanical energy. So it's potential energy plus kinetic energy is equal to the potential energy plus kinetic energy. And we can go right from point A to point C. We don't have to go through point B and do all the in-betweens. So the potential energy at point A is mgh, and the mass of that we don't know. The g is 9.8, and the height of that is 12 meters. Plus the kinetic energy, well, the kinetic energy is 0 because it starts from rest. So plus 0 equals the potential energy at point C, so that's m 9.8 times 4, plus the kinetic energy at that point, which is going to be, sorry, the formula here was mgh, and this is 1 half mv squared. So this is going to be 1 half, and I'll put m in black, and v squared is what we're trying to solve. So now every term here, because it's frictionless, every term here has an m in it, so we can cancel it out. And that's important to note. There is no roller coaster that you've seen that requires you to be a certain mass to get onto it. It's only a height, and the height is because of the restriction of the straps that hold you in. They don't say if you have to have a mass between here and here, and if not, if you have too much of a mass, the roller coaster is going to go too faster, and if you don't have enough mass, it won't reach it. They don't do that because mass cancel out. It doesn't matter what mass you're at. Okay, so let's actually, I'm going to do a little bit of algebra here. This is 12 times 9.8. And then I'm going to take this over to the other side, minus 4 times 9.8. And that has to equal 1 half v squared. I did this because we can see that this 9.8 is a common term. So it's 12 minus 4, 9.8. So this will be 8 9.8 is equal to 1 half v squared. Now before well, I'll solve it. I don't want to say before. Let's just, because it's so close to solving it. So let's just do that. That's 8 times 9.8. I have to multiply it by 2 to get rid of the half. And then I have to square root it. And that will be a velocity of 12.52. Or let's do a speed of 12.52 meters per second. So that's how fast it'll be moving at the top of hill C. Okay, I could have done better calculations here because at no point do I have what the total energy is in my calculations. The total energy is this, but I can't get the total energy because I don't have the mass. So because I canceled out the mass, I was okay on doing what I did. Now, observe, we set, in this question, I set the potential energy to be 0 here. What if I set the potential energy, I moved it. I said, no, I don't want it there. I want it there. So where it ends will be the zero potential energy line. How is this any different? I've made it a lot simpler, but I'll show you the work. E before equals E after, and then you go PE plus KE equals PE plus KE. But by moving, sorry, still starting from rest, this is zero. But by moving it to this location, I've set the final potential energy to be zero, but I have made this mgh equals 1/2 mv squared. Again, the masses cancel, but I have made this h a little bit difficult. It shouldn't be. Everyone would probably get it. It's g, and instead of, I have to just go to that 0 point. And if this whole thing is 12 and this is 4 high, then this is 8 equals 1/2 v squared. And those people that are observant, they'll notice that this is this. I already, by doing this algebra and moving it on over and getting 8 times 9.8, I did this already. And this makes it a little bit simpler. Are you allowed to do that? If you're doing that on a test, you should make sure the person looking at it knows what you've done. What have you done? You've moved the potential energy equals 0 mark. Okay, you've moved where you're measuring the potential energy 0 from. But you get the same answer. Part B. Is there another point in the diagram in which the roller coaster will have the same speed at C? Right here. It'll have the same speed because it's at the same height. Okay, that's important. And further on, if it ever goes back up there. Because at this point, it has the same potential energy. In this case, the second time potential energy is 0, so mgh equals 1/2 mv squared. Part C. Can there be another point during the ride, let's say point D, in which the height of the hill where D is located is 14 meters above the ground? So can it be, I'm going to ruin my diagram here, but can this go down and then go up to 14, where this is 14 meters? And the answer is no. Why? Because at this point, all the energy at this point is in potential. So all the energy here is in potential. That means it's stopped. That means it cannot go any higher. It has no more, and that's where the total energy is. We had the graph where the total energy is on there. It can't go any higher. It doesn't have any kinetic energy at this point to keep going up. Okay. Thank you very much. Hope you enjoyed it.